どうも皆さん、英語で数学、瀬戸です。今回はロピタルの定理について講義したいと思います。In this video, we will go over L'Hopital's rule on computing limits. Consider a limit of this form. The limit as x goes to a of f of x divided by g of x, where f at a is 0 and g at a is 0. Then, can we compute the limit in some other way involving the derivative? Well, let's take a look at the quotient. We can subtract f of a and g of a from the top and bottom because they're both equal to 0. And then we can also divide by x minus a on the numerator and the denominator. We can do this as long as x is not equal to a. By taking the limits as x goes to a of everything, we have that this goes to f prime of a and this will go to g prime of a. And perhaps g prime of a is non-zero. Then that will give us the limit. So let's do a couple of examples. The limit as x goes to 1 of x squared minus 1 divided by x squared minus x. Well, if we plug in, we'll get 0 divided by 0. When this happens, this is called an indeterminate form. And so we can apply L'Hopital's rule. So we take the derivative of the top divided by the derivative of the bottom, and then we plug in 1, and the answer we get is 2. So that is the limit as x goes to 1 of x squared minus 1 divided by x squared minus x. Let's double check this because we can compute this limit another way. We can factor this. These go away. Plugging in 1, we get 2 over 1. And so the limit agrees with the L'Hopital's rule. Let's try another example. Again, we plug in. We'll get 1 minus 1 minus 0. So that's 0 divided by 0. So this is an indeterminate form. So we can apply L'Hopital's rule. We take the derivative of the top and the derivative of the bottom. If we plug in, we get 0 over 0 again. So we can apply L'Hopital's rule once more so that we take the derivative of the top, derivative of the bottom. This time, when we plug in, we get e to the 0 over 2, which is 1/2. And so this limit is 1/2 by L'Hopital's rule. Now let's consider this limit. This is not a quotient, so we cannot use L'Hopital's rule immediately. Now, plugging in, we'll get 0 times natural log of 0, which is undefined. We're taking the limit as x approaches 0 from the right, so you can kind of say this is 0 times negative infinity, because natural log looks like this function, so this will go down to infinity. But 0 times infinity is another indeterminate form, and we can manipulate this equation so that we can apply L'Hopital's rule. Namely, x times natural log of x is the same as natural log of x divided by 1 over x. And now we apply L'Hopital's rule so that the derivative of natural log is 1 over x, and the derivative of 1 over x is negative 1 over x squared. This simplifies to negative x, and as x goes to 0, negative x goes to 0. So this limit is equal to 0. Let's try one more example. The limit as x goes to 0 from the right of x to the x. This is a little tricky. If you plug in, you'll get this very weird expression, 0 to the 0. This is undefined, but it's also an indeterminate form. So we can change this so that we can apply L'Hopital's rule somehow. So how do we do it? Let's let x to the x equal s. Then taking natural log, we'll have natural log of x to the x equals natural log of s. But this is x times natural log of x. And so now taking the limit as x goes to 0 of x times natural log of x, we just did this. This limit is 0. So the limit as x goes to 0 of natural log of s is 0. Meaning, if we exponentiate both sides, the limit as x goes to 0 from the right-hand side of s is e to the 0, which is 1. So this limit is 1.